how to do an implicit differentiation problem that involves finding locations of horizontal tangent lines on an implicitly derived curve. So here is the problem. It says, for what values of x does y squared minus 2x cubed minus 12x squared equals 0 have horizontal tangent lines? So what I'm going to have to do is I need to take the derivative of this curve and find dy dx and solve for dy dx and set it equal to 0. So let's try this. So if I take the derivative on both sides of this equation, that's going to give me 2y dy dx minus 6x squared minus 24x. And then the derivative of 0 on the right side is 0. This, of course, requires me to use the chain rule. When I take the derivative of y squared, it is 2y. But then because it's y, not x, I do need, by the chain rule, to multiply that 2y by the derivative of y, which is dy dx. This allows me then to solve for dy dx. I will move the other two terms to the right-hand side, and then I'm going to divide by the 2y that's multiplied by the dy dx. So I get this. And that is my expression for dy dx. I do notice that I could simplify by dividing top and bottom by 2. So I will go ahead and do that. And then what I want to do is I need to find out what values of x and and what values of y would give me 0. But that would make, I should say, the derivative dy dx equal to 0. Well, I will set that numerator equal to 0, and it's going to give me two solutions. I will factor out a 3x, and I get an answer, or two answers actually, 0 and -4. Now, a common mistake that students would make at this point is they would say that, yeah, for sure, when x is 0 or x is -4, it's going to make the derivative 0, and they would probably choose that answer and move on, and they would have made an error. Because here's what we need to do. Because of the fact that we have y in the denominator, I really do need to take both of these points and take them back to the original curve equation and find the y value that goes with each of those. So I'm going to do that with x equals 0. If I let x equals 0, you can see pretty easily and quickly that y is 0. That means that when x is 0, y is 0. So therefore, this curve passes through the point 0. Well, that's an issue, because that would mean then that if I go to my equation for dy dx and plug in the point 0, I'm going to get a derivative that is not defined, because it will be 0 over 0. So really what I have to do is I have to eliminate x equals 0 as an option. When I stick in x equals -4, right, the other solution that we obtained that made the numerator equal to 0, we could solve for y when we do that. So I'm going to let x equal -4. When I do that, I get y squared minus 2 times -64. That would be -4 cubed minus 12 times 16, and that's equal to 0. Well, this allows me to solve for y. Well, I'll move the 12 and the 16 to the other side. So on my TI-84, when I take 12 times 16, that's going to be 192. But then I have 2 times 64, right, 128. That's a positive 128, but when I move it to the right side, it becomes negative 128. And so therefore I get y squared equals 64. And then when I solve for y, I get two answers. I'm going to get a positive and a -8. Now, I already know enough to answer the question, right? The answer to this question is going to be C, -4 only, because it just so happens that when x is equal to this second solution, -4, there are 2 points on the curve at which there would be a horizontal tangent line. It would be at -4, -8, and -4, +8. What I want to show you is what this is going to look like in Desmos if I plotted this curve. So if I type this in and I type that in, here we do see the curve that we get. Look at these 2 points here, -4, 8, and -4, -8. So those are the 2 points on the curve that we just identified in our analysis here that would make the derivative 0. dy dx would be 0, meaning there's a horizontal tangent line. And here's what's going on over at this point. This function happens to cross itself at 0, and therefore there's not going to be a tangent line there. And so that's what happened, that even though we got x equals 0 made the numerator equal to 0, that did not mean that dy dx was 0, because it just so happens that the y value that goes with x equals 0, as you can see on the graph over here, is y equals 0, and 0 over 0 is not 0. It is undefined, or it does not exist, I should say. So anyways, the answer to this problem was letter B, -4. When x is -4, there is a horizontal tangent line, and there are 2 of them, but only at x equals -4. I hope that was helpful. See you in the next video.